Hello students, in this video we are going to solve some questions asked in CSIR exams on aromaticity. Okay. Let's begin with this question. This was from 2017 December. Okay, the correct match of the circled protons in column P with the proton NMR chemical shift in column Q. There are three different compounds and the protons are encircled. The corresponding proton NMR chemical shift value are given in column Q. So which value matches with which proton? You have to find out and select the correct option. Okay. Look at this one. What is this molecule? This is 14-aniline. 14-aniline is aromatic. As per Huckel's rule also, it is aromatic. Odd number of 7 pairs of pi electrons, it is aromatic. And the proton NMR, if you record the proton NMR of this, you get two sets of protons. One is internal protons, the other one is, another set is peripheral protons. Okay, this is one such internal proton. So, internal protons are highly shielded, because they come in the diamagnetic zone. Okay, the induced magnetic field generated by this proton will oppose the applied magnetic field. Okay, the internal proton opposes the external magnetic field or applied magnetic field, so they are shielded. Okay, but peripheral protons, outer protons, will be in the aligning zone. They will augment with the applied magnetic field, so they will be de-shielded. Internal protons are shielded. Peripheral protons are de-shielded. So here, this is internal proton. It is shielded. It goes less than 0 ppm. So the right one is given here. But if we come to these two, okay, let us see this one first. Okay, how many pi electrons? 1, 2, 3, 4, 5, 6. 6 pairs of pi electrons. 6 is an even number, so this molecule is supposed to be anti-aromatic according to Huckel's rule. This example is straight away given in Jerry Match. Okay, he discusses a point in that it is, he categorizes this set of molecules into two types. One is diatropic, the other one is paratropic. One is diatropic, other one is paratropic. Paratropic. He categorizes two types. Diatropic means, the example is the 14-aniline what we have seen. 14-aniline, 18-aniline, all are diatropic molecules. How can we say that it is diatropic? Means the inner protons, okay, inner protons will be shielded. Outer protons will be de-shielded. Outer protons will be de-shielded. But if we come to paratropic, inner protons will be de-shielded. Outer protons will be shielded. Okay. So paratropic is just opposite to diatropic. Diatropic molecules are aromatic. Paratropic molecules are anti-aromatic. Okay. So paratropic molecules, inner protons will be de-shielded, outer protons will be shielded. Okay. So the example that we see here is paratropic. That is why it is the inner proton. Look at this inner proton. It is de-shielded. The value goes here. Okay. As per Huckel's rule also, it is anti-aromatic. Okay. So as per proton NMR also, it is anti-aromatic because it is paratropic. Inner proton is de-shielded. And this one is here. This is not an aromatic compound, just a olefin. Olefinic region are supposed to appear from 4 to 6 ppm. Since there is 2 electron withdrawing carbonyl groups, it is slightly de-shielded. Okay. So 3C, 1B, 1B, 2A. 1B, 2A, 3C. So option C is the right answer. Okay, option C. Okay, 1B, 2A, 3C. Okay, right. We'll go to the next question. This was asked in 2018. Okay. The correct match of the protons in column A with the proton NMR chemical shift in column B for the product of the following reaction is, here is the reaction, cyclooctatetraene, okay, a non-aromatic compound. The tough-shaped non-aromatic compound is treated with a proton. It gives a cation, okay. This cation gives signals in different regions. Actually, we get four sets of protons. HB is one type, HA is other type, and these two are one type, and these H2 to H6, these five are other type, okay. So, four types of protons, we get different signals. And the H2 to H6, first of all, this problem is about what? It is about homoaromaticity, okay. They have uploaded a video on homoaromaticity exactly with the same problem, okay, the same molecule. Please go through it, okay. So these H2 to H6, they are in one plane, even H1, H7 also one plane, but H2 to H6, they are exactly aromatic, perfectly aromatic. They give signal from 7 to 9 ppm, 7 to 9 ppm. And if you look at this one, HB and HA, both are methylene protons. They are supposed to give signals from 1 to 2 ppm. But this is exactly above the plane of the ring. So that means if you apply the external magnetic field from here, okay, the induced magnetic field generated by this HB will oppose the applied magnetic field, because this is in the diamagnetic zone. Since it is diamagnetic zone, it should be less than 2 ppm. Okay. Since this one is in the aligning zone, paramagnetic zone, since it is in the aligning zone, it should be greater than 2 ppm. Okay. This is less than normal methylene region. This is greater than normal methylene region, because this is in the opposing zone, this is aligning zone. This is shielded, this is de-shielded. Okay. Let us see now. 7 to 9. Okay. H2 to H6. H2 to H6. Okay. It is already there in the 7 to 9 ppm. This is the right one. And H2, HB should be shielded less than 2 ppm. Okay. So this is less than 2 ppm. HA more than 2 ppm. It cannot go to 6.4. More than 2 means it is alright. It cannot be de-shielded to this extent. Okay. And the remaining is okay. So HA to HB1. I mean P is 2, Q is 1. P is 2, Q is 1. R is 3, S is 4. Okay, option A. Option A is the answer. Okay. Okay, let us see this one. Next question. This was also asked in the same year, I think. The correct order of pKa values for the following compounds X, Y, Z is. pKa represents the acid strength. Lower the pKa, stronger is the acid. Okay. So after this, the one which has lowest pKa is going to be the strongest acid. Okay. So before finding out the acid strength, let us see the conjugate bases. Let us see the corresponding conjugate bases. If you see the conjugate base, minus, and here the conjugate bases, everywhere cyanide, and there is a negative charge here. And here the conjugate bases, here it is okay, there are 3 conjugate bases. Out of these 3, let us see these 2 now. These two are aromatic. If you look at the cyclopentadienyl anion, here also cyclopentadienyl anion. Both are aromatic. But this one is more aromatic, this one is less aromatic. What is the reason? Reason is annihilation. We have already uploaded a video on annihilation. Annihilation. Okay. The reason is more the annihilation, less aromatic. So here annihilation is more, so this is less aromatic, this is more aromatic. Okay. So the anion, out of these two anions, this is more aromatic, more stable. That means this will form very quickly. So this will donate the proton easily and it will form this. Okay. Since it donates the proton easily, means this is going to be the more acid, strong acid. Okay. If I compare Y and Z, Y is the stronger acid than Z. Y is stronger than Z because the conjugate base is strong. Okay. Y is a strong acid. Y is strong means the pKa value, it should be opposite. pKa value should be less. Okay. Y pKa value should be less than Z. Okay. Let us see where pKa of Y is less than Z. Here pKa of Y is greater than Z. Here it is greater than Z. Here it is Y is greater than Z. But here only Y is less than Z. So this is answer. Okay. You look at X now. This X. X comes in between them. Okay. X comes somewhere in between these two. Because the conjugate base of S, this anion, is stabilized by two electron withdrawing groups. This side and this side. It is flanked on both sides by two electron withdrawing groups. So it is even more stable than this one. Okay. So the stability of this anion comes in between these two aromatic anions. So the acidity also comes in between these two. Okay. So for your information, let me write the pKa values. The pKa value of this one is minus 11. Here it is around 22. Okay. If I remember properly, this is around 18, but I am in doubt. Okay. I am in doubt. Okay. So minus 11 means very strong. It is stronger than strong acids like proton and HNO3. Okay. Nitric acid. So that much this is strong. Okay. That is why the Y is the least value. Okay. So answer is 3. Let's see one more problem. Yes. The correct statement are about the reaction of X and Y with sodamide is. Sodamide is a strong base. What is the role of that? Its role is to remove the proton. If it removes the proton here, okay, if the proton is removed here, what will I get? I will get 3pH, pH and an anion. If a proton is removed here, I will get pH, anion, another pH and one pH. I get two anions. If I look at these two anions, okay, sodamide will remove protons and it will give the conjugate bases, the two anions. If I look at this anion, this is nothing but cyclopropenyl anion. Cyclopropenyl anion is anti-aromatic. We have already seen. Anti-aromaticity is a destabilizing phenomenon. So this is unstable one. But here, this anion is stabilized by 3 phenyl groups by electron by resonance. Okay. So in that way, this anion is more stable than this one. Here also you have phenyl group, but it is destabilized because it is by anti-aromaticity. The corresponding cyclopropenyl anion is anti-aromatic. So this anion is unstable. This anion is comparatively stable. Okay. So this one will lose the proton quickly. Okay. Because by losing it can give a stable anion. So this molecule is more acidic. Okay. So more acidic means it reacts faster with the base. So X reacts faster than Y. Y reacts faster than X. X reacts faster. So this is the right statement. And let's see the other one. X and Y behaves as Lewis acids. Are they Lewis acids? Lewis acid means electron acceptors. Okay. Electron pair acceptors. But here they don't accept electron. They lose a proton. That means proton donors. Proton donors are protic acids. That means, I'm sorry, proton donors are bronze-state acids. Okay, so X is a stronger bronze-state acid than Y. Of course, X can give a better cation, better anion. It can't do so. So it can easily donate this proton. It is a stronger bronze-state acid. So D is also a correct statement. So A and D. Option 2 is the right answer. I hope you understood. If you have any queries, any comments or any suggestions, please write down in the comment box and we will meet in the next video. Wish you all the best. Thank you very much.